What is the best sanding grit for hard wax oils? And is sanding higher actually better? To answer this question, we've invited the team at Mirka Canada to scientifically test the penetration of TopOil by applying it to woods sanded to different grits using Mirka sanding tools. We'll be working with American walnut, white oak, and maple, as these are some of the most common wood species found in North America. We'll be applying Osmo TopOil. TopOil is a high solids hard wax oil designed to give a durable and protective finish. For this test, Mirka will be using 4 different sanding grits. They'll be starting with 120, then moving to 180, 320, and 400 grit sandpaper. Each grit represents a different level of smoothness and texture, and our goal is to determine how these sanding grits influence the ability of the oil to penetrate the wood fibers. So to start this test, we'll sand 4 different pieces of wood with each of the specified sanding grits. We begin with 120 grit, which creates a relatively rough surface and is typically used for hardwood flooring. Next, we move to 180 grit for a medium smooth finish, which is often used for general purpose sanding. Next is 320 grit, which is finer and is typically used for sanding between coats of finish. And finally, 400 grit to achieve an ultra smooth surface, ideal for very fine finishing between coats. With our sanding complete, it's time to apply our Osmo TopOil. For the best results, we're going to apply the recommended amount of 60 grams per meter squared. We achieve this by applying 2 very thin coats using a high-quality brush or an Osmo microfiber roller. As we apply the TopOil, we'll observe how it spreads across each surface. The oil should ideally penetrate the wood, enhancing its natural beauty while providing a protective layer. With our TopOil applied, we're going to let these pieces sit until they are fully cured. Once our samples are ready to go, we can test them to see what effect the different sanding grits may have had on the overall performance of the finish. We do this by stamping a grid onto the wood that indicates specific time intervals. We will apply water, red wine, and soda at each time interval and remove it once the time interval has elapsed. This method illustrates how well the oil has penetrated across the different sanding grits and gives us a good indication of whether or not sanding to higher grits affects the overall durability of the finish. At this point, our samples are handed over to the Mirka lab team for additional testing. The lab team uses a Mirka shark blade, which is a sharp carbide tool used for removing finish imperfections, to shave off any hard wax oil on the wood surface so we can observe how the oil has interacted with each sanding grit. We were able to observe that on the finer sanding grits, there was a dust and oil mixture that did not harden well and was easy to remove from the wood pores using a needle. This indicates that the finer grits may produce dust that is trapped in the wood fibers, affecting the ability for oil to penetrate. Next, we take a finished wood sample and cut into the wood fibers at a 20-degree angle. This allows us to accurately measure the depth of oil penetration into the wood. Now, we're going to take a closer look at our results. We measured the oil penetration depth for each grit, and this is what we found. For 120 grit, we found a penetration depth of 0.16 millimeter. This grit shows the deepest oil penetration, indicating that a rougher surface allows the oil to soak in more effectively. For 180 grit, we found a penetration depth of 0.1 millimeter. While still significant, the penetration depth is less than that of 120 grit. With 320 grit, we found a depth of 0.05 millimeter. The penetration depth is greatly reduced, suggesting that the smoother surface resists oil absorption more than the coarser grits. Finally, a 400 grit sanding shows a penetration depth of 0.015 millimeter. This grit shows minimal penetration, demonstrating that an ultra-smooth surface can significantly hinder the ability for an oil to penetrate and absorb. These results confirm that as the sanding grit becomes finer, the oil's ability to penetrate the wood decreases. The finer grits produce finer dust that fill up the wood pores, making it challenging for the oil to properly penetrate. So what exactly does this mean for your woodworking projects? If you're looking for the best stain and water resistance, then consider using a grit between 120 to 180 as your final sanding grit. These grits allow the oil to soak in more thoroughly, providing better protection and enhancing the wood's appearance. Because Osmo wood finishes are considered hard wax oils, they contain both natural oils and waxes. The oils penetrate the wood surface. This fine layer of waxes produces an extremely smooth finish. This means that applying Osmo to wood sanded to coarser grits, even like 80 or 100 grit, still gives you an extremely smooth surface. This means less time spent sanding and overall a more durable result. Because of this feature, we suggest that your final sanding grit be no higher than 120 for flooring and between 150 and 220 for fine furniture. Osmo would like to say thank you to Mirka Canada for partnering with us and providing their expertise on this topic. You can explore Mirka's dust-free sanding tools, power tools, and more on their website, mirka.ca, and you can also look for them at your local hardware store.